Hello. This time we're going to spend some time on the basics of graphene. Because I've been receiving a couple of questions about, well, how do we actually process them? How do we actually graph something? What would be the graphical representation of an object? Well, it really depends, right? So I'll start with the most basic thing. We're going to plot a few points. But in order to do that, we have to introduce what we call the coordinate plane. So what is it we do? Well, very first thing, I'm going to write it here. We're going to start with a piece of paper, right? Flat paper. Like the one that we have here. Secondly, we're going to draw a line. It's going to be the first line that we're going to draw. Okay? We'll just draw it here. Now, secondly, I'm going to draw a line that is perpendicular to the first. And this is going to be the second, perpendicular to the first. Okay, so let me see how we can do it. Okay, something like this. Now, as a fourth step, I'm going to choose a direction on the piece of paper and associated with the lines for the first line. And well, any line has two possible directions, so I'm going to indicate that the one with the arrow stands for the positive. And well, I'll do the same thing on my fifth step as choose a direction for the second line. And well, this time I'm going to indicate with an arrow that one going upwards, at least from the perspective that we have, it's the positive direction. So the opposite direction, we're going to call it, for the lack of better language, negative, right? Better idiom. Now, what we're going to do next is to, well, look, there's a unique point of intersection. This is known from the beginnings of geometry. Well, we're just doing just some geometry. So I'm going to call the common point of intersection between these two lines, the origin. Oh. Now, sixth, we're going to select a unit of measure and we're going to use it to label our lines, right? So let me think, like, well, imagine that I have a ruler and I place it from the origin going in the positive direction of the first line, and then I'll take the ruler and place it right one after the other, right? So I'll make a second label here, another one 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 here. Then if I wish, I also reverse the direction, right? Place one here, one here, one here, one here, one here, and then so on and so forth. Now, the same is to do it to the second line. And what I'm going to do is keep exactly the same measure. So since going up will indicate the positive direction, this would be that one. Then I place my ruler. Now that's the second, third, fourth, fifth, sixth, seventh, so on and so forth. Okay, now what is customary is to also, among the labels that we place, also indicate it with a number, right? Which is actually the number of units in that given direction. So this is the first unit, second, third, fourth, fifth, sixth, seven. This one, 1, 2, 3, 4, 5, 6, 7, and so on and so forth. Okay. So what is that we're doing here? Let's represent it. We select the unit of measure. Think of this as a ruler. And add some markings as you slide the ruler on the first line, just as we did. Now, well, let's add some labels also to the instead of just saying first line, second line, we also have other names. We typically call the first one X and the second one Y. Okay. Now, imagine yourselves that now we have a point on this plane. And the point that I'm going to select is just this one. And I'm going to label it as P. And you say, that's my point P. That's just a point on the plane. But now that we have made all these arrangements, right? We have constructed these two lines, add those labels to it. What can we do? Well, we can associate with this point two numbers. And in what way? Well, let me do this. What I'm going to do is to draw a line that passes through P that is perpendicular to the line X. Then I'm going to do the same for the line that we call Y. I'm going to drop a line that passes through P that is perpendicular to Y. There we go. Now, what I'm going to do is to record the numbers that I touch, the labels on the X line and on the Y line, that we also usually call this the Y axis and the X axis. These are just names for those lines. So then you say, well, what is the label on the X axis for the line that we just draw? Well, the label is 2, right, for that one. And the label for on the y-axis for the line that we draw, that is perpendicular to P, perpendicular to Y, passing through P, is 3. So, let's say it. What we have now is that P is associated with an ordered pair of numbers, namely 2, 3. Now, the association also goes in the opposite direction, saying that if I have another pair of numbers, I can construct a point on the plane. How so? Well, let me start like this. Take the order paired 5, 7. How is it I'm going to reconstruct a point? Well, easily. What I'm going to do is to draw a line that is perpendicular to the x-axis exactly at the label that we have as 5. Okay? And then Well, that completes that part. Then I'm going to draw a line that is perpendicular to the y-axis, the second line, that passes through the label 7. Okay, so I'll do it here. These two lines have a point of intersection, that one, that I'm going to call Q. And then, well, look, what we can do is now ask ourselves a few questions. Well, now that we have done all of this, you can say, well, what is the distance from P to Q? And we can talk about distance because we have a unit of measure that we can use to actually measure things, right? So what is it we're going to do? Well, we're going to draw a line joining P and Q. And then we're going to take our standard measure and see how many times it fits here. That will be the length, right? The distance from P to Q. Well, in this case, we can do it manually, or, well, we can resort to other mechanisms, like the Pythagorean theorem, that says that when you know the lengths of the side of a right triangle, you can also know the third. As long as you know 2, you can know the third. And in this case, well, that would be too much of a complication, because we can see this. We start here at 2 and we end at about 5. So that means that if we measure this length, the result has to be, well, the difference between 5 and 2, and that would be 3. What about this length? Well, kind of the same idea. That would be the difference between 3 and 7, so that is 4. And in that case, what would be the distance from P to Q? Well, I think we all know the relation, that if we call this length or this distance d, then we have that d squared is equal, being the opposite side to the right triangle in the right triangle, would be 3 squared plus 4 squared, which of course indicates that d is equal to 5, right? So the distance in the units that we selected from the point P to the point Q is 5. Well, but we can also provide different formulas for this, right? So we now have an efficient way of measuring distance. All because we took the time to construct what we call this coordinate plane, this Cartesian plane, that has these characteristics. We have two perpendicular lines with predefined directions for each of them. Where would you place labels associated with the unit of measure? Now, this is just the basics. Now that we have this at hand, we can then produce, well, if we can produce points, can we produce lines? Can we produce circles? And then have a similar relations as the ones that we just provided here. To points, we have two pairs of numbers, and to two pairs of numbers, we have points. Well, what would be the association of circles and lines, for example, in this case? Well, wait for the next video.